Back in episode 94 of Mobycast, we showed how Amazon Elastic Container Service, or ECS, makes it easy to inject sensitive data into your containers. However, ECS only injects secrets at container startup. It's up to you to ensure that the container is restarted if secrets are updated. But who wants to manually restart containers? In this episode of Mobycast, Jon and Chris are back to provide an automated solution to this problem. We show you step-by-step how to leverage CloudWatch Events and Lambda to automatically update your container secrets. After listening, you'll be able to automate all things. Well, at least for updating container secrets. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts Jon Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, Jon. It's so good to be back.
Yeah, good to have you. Chris, are you doing anything next week that's interesting?
Let me think about that. Am I doing anything? Oh, yeah. I'm getting onto a plane, multiple planes, and flying halfway across the world to Brazil to meet up with the team for our annual company retreat down in on the beaches of Brazil. So have quite a bit of travel in store. But looking forward to it.
You're not making me feel bad for you, Chris. That's not working.
Oh, come on. I've got to go. I've got I think 3 different segments, totaling 30 hours of travel each way. So of course you've got the same shindig, right?
Yeah,
so,
I do. Yeah. I guess I'll be there too.
Yeah. You're going to come?
Yeah.
Right on.
Yes, I'm so looking forward to it. It's one of my favorite times of the year and just love meeting up with the team and kind of do it. It's like we kind of do some of this training that we do for you, our listeners, to the team. Because oddly enough, not everyone there is rabid Mobycast listeners. So we sort of have to repeat ourselves. But for anyone on the team that is listening, thank you. And All right.
Shout out to
Faku. Yeah. Okay, so a while back, we did sort of a classic series on secrets management. We talked about different AWS services and our sort of roll your own way of managing secrets. Big part of keeping any application, working with a good security posture in the cloud. That we also talked about how things have changed over the years, with how you manage secrets from sort of I guess the big thing that changed with it is just cloud computing itself. Like it's no longer one build person who kind of has all the secrets and builds them into the executable that then gets deployed onto machines in your data center. And it's instead an orchestration of moving the secrets from a place where they're stored behind lock and key into a running executable. So we talked a lot about that in episode 94 and 93. So what we didn't talk about, and we just kind of left as an exercise for the user, is what do you do if you change your secrets? Like, how does your application deal with that? Like, how do you actually make it so that if you change a secret, your application doesn't just fall on the floor? And Chris and you and I were talking before this episode and just sort of saying that never gets talked about. Like always, every tutorial is always about here's how you store your secrets. Here's how you rotate them. They never talk about the hard part, which is what you do after you change them. Were you supposed to go update 100,000 machines? You have a huge deployment, update 100,000 machines with the new secrets? Of course not. It's and you also gave the example, Chris, of it's sort of like when you lose your credit card. Like you got to go to every website that had your old credit card in it and update it to your new credit card, which is just terrible. So yeah, Chris, maybe you can take it away from where I just left us and talk about what you're going to say in terms of dealing with the client side of secret rotation.
Sure, yeah. And so this is an extension again of those 2 episodes that we did on secrets management. again, episodes 93 and 94. And in particular, we went into detail about just how easy it is to have integration with secrets management with ECS, containerized applications running on ECS. In particular, there's two systems of AWS that do secrets management. So there's Systems Manager, Parameter Store, as well as Secrets Manager. And both of those integrate in seamlessly with ECS by literally there's no code involved at all. You just update your task definition file for your container to specify which secrets you want injected into your container. And so one of the things we pointed out during that, though, was like this only happens at container startup. And so if you make any changes to those secrets after the container is started up, the container's not going to see it, right? So that's what we left as an exercise to the reader is like, well, how do you deal with changes to secrets? You need to do something here, and it could be something as manual as you just go in and manually reboot your containers so that they restart up and get the new secrets, or something else. But kind of pointed out this is one of the issues that you'll have to deal with. And as we all know, things rotating credentials and secrets is just part of the best practice. And we did talk about how these secrets management services, especially Secrets Manager, AWS Secrets Manager, has built-in support for credential rotation. So it's literally like you can click a button or you can make a single API call and it automatically rotates secrets for you like for database credentials for connecting to an RDS database instance. But as you point out, Jon, it's like anybody.
Your credit card number just changed.
Yeah, exactly. Anyone can do it. You got to go now. It's like, well, how do you update all your clients, right? That need to know that changed. And so that becomes like the hard part, right? So like, this is why we resist doing these credential rotations, right? Like, ask yourself now for your applications, if they're making if they have to connect to, like, say, a database, they have to somehow get configured with the database connection string and make that connection. Well, how are they getting that configuration information? And what would happen if you were to change the credentials underneath them? Like, how would you deal with that? And so that's not necessarily easy to do. And it is work. And sometimes it's messy. And that's what is kind of like the main sticking point for like why we don't practice this good hygiene. So today's episode, we're going to talk about, like, in particular, when you're using secrets management with ECS and your secrets are stored in Parameter Store or Secrets Manager, how can you kind of automatically detect when these changes happen and then take action so that your application continues to run seamlessly and is made aware of those changes that were made.
Right. And you're so right. Like the last time I was building some serverless code, I remember it was the first time I used Secrets Manager, and I remember reading on the screen, like on the AWS console screen, it was like, oh, click here to automatically rotate secrets, or do you want automatic secret rotation? And I was like, oh yeah, heck yeah, I want that. And then I was like, wait, but what's going to happen if I do that? And after about 30 seconds of reasoning and thinking about it, it was like, I'm just going to do that. Worry about that later. And I never got to it.
Absolutely.
So here we get to it.
And I think, and honestly, that's probably like what 99% of people using Secrets Manager, at least initially, will do as well, right? Is like
it's so intriguing. You're like, oh yeah, I want that.
But you'll see those two radio options, and you'll be like, oh, it would be cool to do the automatic rotation, but what's it going to break? And so there's things I need to do. So I'm just going to keep with the manual rotation to start with. Yeah.
Manual being a synonym for never.
Indeed. Yeah. Which, by the way, I mean, it was the exact same experience I had as well when I first started using Secrets Manager. It's like I knew, like, I can't enable automatic rotation. There's some stuff that I need to do in order to feel safe with turning that on. Right. So that's what we're going to talk about today.
Cool. So what are the two things you need to do to feel safe to turn that on?
Yeah. So
two simple things.
Two simple things. Yeah. And so again, this is in the context of where we have a containerized applications running under ECS. We're injecting secrets into the containers as environment variables through that integration. And we want to be able to rotate those secrets while the containers are running. And so and we want all this just to work without any interaction on our part, to have a fully automatic solution for dealing with it. And so we're going to describe a technique for doing that. And it's a 2-part technique. And it's really just two things. One is like, hey, get notified when changes happen to those secrets. And then once we have been notified, then take an action, trigger an action based upon that to go and update our containers. And so it's just 2 steps.
No, but thanks for listening, everybody. We'll talk to you next week. All right. So first, we're going to take an action. We're going to get notified. I think we have a little bit more to say about that.
Sure. Okay. So step 1, like how do we? So we need to get notified. Like we have to know in real time when these changes happen, so that we can then do part 2, which is respond to them. So to get notified, we're going to use CloudWatch Events. And so we've talked a lot about CloudWatch Events, kind of informal basis all throughout Mobycast. I mean, it's really one of those important key backbone components of any cloud native architecture running inside AWS. It's the core for event-driven processing.
Right. It came up so much during the well-architected framework episodes. That's where we really touched on it a lot for people listening.
Yeah, I mean, and
more.
CloudWatch itself is massive, right? Because so we're talking about CloudWatch Events, which is literally just one of the bullets underneath CloudWatch as a service.
Right.
So CloudWatch includes like all the metrics, which is a whole thing in and of itself. It's dashboards, it's monitoring, it is alarms, it is logging.
I like to think of it as like the Unix core, like little apps, but for the cloud. So it's like LS, it's like looking at /var/log, it's like cron, like all of those things, but for the cloud. Yeah.
And it's quite a bit there, right? So so we're talking about we're going to be using some CloudWatch events, and so what are CloudWatch events? And really what it is it's used to deliver basically a near real-time stream of these pieces of data that describe changes in AWS resources, right? So it's all about like state changes. And so there are these packets of data that get delivered as a real-time stream. Those are the events. And these are being emitted by quite a few of the various AWS resources that are, make up the ecosystem. So things like EC2 and ECS and Kinesis and like just various, all the just the many
everything.
Of the core services.
S3.
It's not, it's not everything. So, and we're going to talk a little bit more about that, but it is quite a bit. And there are ways to kind of make it encompass almost everything through other techniques. But for now, let's just think of this as like this near real-time stream of these data packets that describe state changes to AWS resources.
Mm-hmm. So you're saying you cannot pass the certification exam by assuming it's everything, but you can probably get by if you assume it's almost everything.
Yeah, and again, you could argue that it is everything through other techniques as well.
Sure.
So it does give us broad coverage, right? For sure. And so it's, for the most part, like if you do want to know about something changing, like this is going to be the first place you should look to is CloudWatch events. Right?
Yeah, I think that's a good way of putting it.
Yeah. So just some terminology we should probably talk about. Like there's kind of like 3 main components to CloudWatch events. And so one is the events themselves, right? So we talked about this, that the event indicates a change in the AWS environment. And we talked about this, many of the AWS resources, such as EC2 and ECS and whatnot, will generate these events when their state changes. So they'll emit these events onto that event bus. And then it's also possible for you to generate your own custom application level events and publish them. So it's not just limited to AWS resources. If you want to, you can actually use this as your event bus as well for your application. So that's events. And a second component are rules. And so rules are pretty important because what they do is they specify a matching of incoming events and then specify how they should be routed to targets for processing, right? So this is it's one thing just to, you don't just want to see these events, right? You want to actually respond to them. And so rules are the glue that basically says, given this input, this is the action I want to take. And so very, very important when we're working with CloudWatch events is to have these rules. And then the third component is targets. So the target is what processes these events. And there's many different types of targets that are supported by CloudWatch events. I think there's like at least 15 or 16, and it continues to grow. Maybe it's like 20 now, continues to grow. But some like really common use cases for targets are, Lambda functions, SNS topics, or CloudWatch log groups, right? These are all, so, you have an event that comes in, there's a rule that matches it, and it then gets routed to a target, like a Lambda function. Say, hey, Lambda function, here's this event, and now go take an action with code.
Okay, so just for example, like an event might come in, the rule says, oh, that's just needs to be logged, so send it to this log group. Another one comes in and it's like, oh, whenever we see that, it's supposed to run this Lambda function, so send it to the Lambda function. That kind of thing?
Yeah.
Okay.
And so rules can actually specify one or more targets, right? So and those targets will be processed in parallel. So if you wanted to send it to both CloudWatch and Lambda, you could do that.
Cool.
So those are the primary components that make up CloudWatch events, and we'll be continue to talk about those quite a bit. So events, rules, and targets. And so let's talk a little bit about, okay, what are these events? We talked about there are these pieces of data that describe these changes to AWS resources. So what are they? And at the end of the day, it is just a JSON. They're specified as JSON objects, and they all have a common top level structure to that JSON object. So this same top level field. So we're not going to go through what all those fields are, right? But they do some of the important ones really are source and detail type. So these are, you can always expect that your CloudWatch event structure is always going to have a source property and it's going to have a detail type property. And basically the combination of those two fields serves to uniquely identify the emitter of it, right? Which is going to be important because keep in mind, like there's just for every different type of AWS resource is an emitter, right? And they all are going to be emitting different types of information, right? So like if EC2 is reporting a state change to an EC2 instance, well, that information is going to be different than if ECS is reporting a state change to a ECS task, right? They look different. There's different data there. So there's going to be...
Well, I just want to say, and going back to what we're trying to do, we're trying to know when a secret changed or got rotated. So we're going to do something on our ECS cluster when that happens. And we don't want to do something to our ECS cluster when a new file got added to an S3 bucket. We don't care about that.
Exactly. Yeah, exactly. Right. So these event structures, they have the common top level fields, which basically allow you to say, okay, I can uniquely identify who the emitter is, and then there's a detail property in that top level field, and that is where the emitter puts all their custom fields, right? That's almost assuredly where you're going to be extracting data out of to understand like what happened with this event, right?
Mm-hmm.
So something to keep in mind is like that you'll be, when you start working with this, it'll hit you like a ton of bricks. Like you're going to have to like, well, what does this detail property look like? Is going to be one of the first problems that you're going to be faced with. Right. So it's like, cause you can't, how do you even deal with it? Right. If you don't know what it looks like. So you need to know what that schema is, what that structure is to it.
Sure.
And it's going to be, again, it's going to be different for every emitter. So, how do you figure that out? And so there's definitely a few different ways, right? So you can look for in documentation. So in some of the AWS documentation, for, various AWS resources, you'll kind of see like examples of like, okay, here's what a CloudWatch event looks like when emitted by this particular resource. So you may find some information there. You may find other resources like showing like the sample code or just tutorials or whatnot might be a good place to find it.
You could ask Chris.
Excuse me?
You could ask Chris.
Yeah, you could ask Chris. No, don't ask me. But I guess what I'm trying to get to is that like it would be nice to have like this one place where you could go to where you could say like, okay, here's my AWS resource and I want to know exactly what this looks like. Like show me an example of it. And that really doesn't exist.
Hashtag AWS wish list.
Well, okay, so they're kind of working on it. So this might be a good time to do a little bit of a segue. And John, you and I were talking about this the other day, a little bit, and it's kind of like this. You were expressing like this. Like this fact that like, man, there are so many different types of event buses, right? And patterns, these event driven patterns. And so you have things.
I mean, you just explained to me the features of CloudWatch events, and it's like, there's another AWS service that works awfully similarly. And I could probably use it for a lot of the same stuff. Like, how do I choose which one to use and when? Like, and I'm talking about SQS, SNS, even Kinesis you can use for as an event bus, like Kafka. Hey, why don't I use Kafka? Like there's so many ways of moving events around in AWS.
Yep. Indeed. And so they all came about for various different reasons and specializing in particular use cases.
Yeah. One reason, Chris. Money. They're all there for the money.
The money, yeah.
It is all about money. But yes, they also have like actual product reasons. It's true.
That's right. Yes, SQS is the big money man for AWS, right?
Right.
Yeah. Okay. So we have all these different types of event buses and whatnot. Part of it is also just like, okay, like let's be real. It's about history. It's like, started off with, you got to have something. So, AWS first, SQS is the grandfather of them all, and just started off with just like a simple message queuing system, right? And then like, we need something like more real time that could support different types of fan out capabilities, right? So SNS came into play, right? Because it could do fan out, and vice versa. And then we had CloudWatch events, right? And so CloudWatch events became like this core platform for dealing with AWS resources. It really wasn't, to start off with, it wasn't possible to publish events, custom events on that bus, right? Yep. Like it was really just like, okay,
tell me what's happening in cloud.
Yeah, exactly. Yeah. But it's definitely evolved and whatnot. We're now at the point where, this is what AWS is launched in 2006, I think, or so, right? So we're, they're 13, 14 years old, mature now in this process. They can take a more comprehensive view. So there is a new service that they launched last year called Event Bridge. And this is interesting. It's also kind of confusing. I think AWS really has their work cut out for them in kind of educating people on what this is, because really at the end of the day, like the end goal is like CloudWatch Events is going to be renamed EventBridge. But they have to slowly do this, because if they just did it, it would just confuse the heck out of everyone, right? Because so many people...
But it has already, right? It sort of doesn't matter. But the nice thing is, at least the people that are using CloudWatch Events, they don't feel like they just got their rug pulled out from under them. So I think that's where they wanted to avoid the confusion. And
kind of like, but the same time, like if you ask like 90% of CloudWatch Event users, like what's EventBridge, they'll say, I don't know.
Right. Yeah. And I'm seeing that play out in real time on this Slack group that I'm a part of, where there's a lot of AWS conversation. People have no idea.
Right.
They're not sure.
Yeah, exactly. And I think, again, that's kind of like by design on AWS's part, because if they really put this front and center and really highlighted it, it would just confuse the heck out of everyone. So the takeaway here is that EventBridge is kind of the evolution of CloudWatch Events. It represents the extension of CloudWatch Events to now not just be for AWS resources, but to be any kind of bus that you want, and multiple buses. So not just the system bus for AWS resources, but like say, if you have a SaaS application and you want it to have its own bus for having these events that are published that folks can then write rules for and then take actions on, you can use it for that. So it's this much more extensible system, not just for AWS software and resources. It's for basically anything. And so it's the next evolution of CloudWatch Events. And it is going to be, all this is going to come under the umbrella of EventBridge, but it is going to be a gradual process, right? Like they have their work cut out for them from just a user education standpoint of like, how do they introduce this change?
Right.
And so we're kind of in this middle area, this gray area, where EventBridge does exist. It's actively being worked on and features are being added. But CloudWatch Events still exist. Nothing's really changed with that. Like you can still go to the CloudWatch console and click under events and see your events there and create events and update events and create rules and targets and whatnot. So, but keep in mind, like one of the things you will run into is that these are, at the end of the day, they're the same thing. So if you create an event rule and under CloudWatch, if you were then to go into the EventBridge console, you would see that same event rule in EventBridge, right? So it will show up as both an EventBridge rule and as well as a CloudWatch event rule. So with the exact,
you get a twofer.
The exact same information, right? So be aware of that. You may notice that so EventBridge is underneath the EventBridge brand. They are continuing to evolve that and add features. And so there's some additional there's additional new features now in under the EventBridge brand that just extends the capability of like rules, right? And the ability to write rules and in particular around pattern matching and whatnot. You won't see that advertised underneath the CloudWatch Events brand.
So is that clever marketing, Chris? Like, is that the whole point? Like, okay, we're going to keep them both, but really EventBridge is what it is. It's the new thing. That's where we're trying to push people. Instead of having like hey, everybody, come learn about EventBridge. Like, hey, it's all going over to EventBridge. Instead of that, it's sort of like, oh, you want that feature? Go down the hall. It's EventBridge. Like, go check that out. That's where it is. Mm-hmm. Like, is that the idea? Is that the sort of like marketing channel for this? Like, I think,
I think that they have to do that, right? Otherwise, it's even more confusing. Because if you now have to kind of like publish like these changes to two different things, just like could you? I mean, just think about like in the what's new listing for AWS. So the first one says, now, regular expression matching for event patterns and Event Bridge. And then underneath of it, now regular expression matching for event rules and CloudWatch events.
Right. Yeah,
that would be really weird and confusing, and it would just make it so that they really could never deprecate the one for the other one. So yeah, I think this will definitely be the pattern going forward. Like, the thing to keep in mind though is that at the end of the day, Event Bridge is CloudWatch events. So and it's using the exact same APIs. It's the exact same services it's using. It's just, again, that rebranding of it to represent the fact that it's extending the use cases. So it's not just for the AWS system bus. It's for extending that to other types of applications and SaaS services.
Right. And don't we computer people like to say that Event Bridge is a superset of CloudWatch events? Is that how we like to put it? That's how we like to put it.
Yeah, but the thing, so just to be a little bit
poke at that,
a little bit of pedantic, is that it's not actually a superset. It's literally just a renaming. But isn't it a superset though? Like it doesn't give you the ability to have your own buses and stuff that you can't do with CloudWatch events. So like CloudWatch events is like that's your old bus. Hey, your old bus is still there in the new brand, and you get to make these new buses. That's how I'm seeing it. It's really like you can think of it as like it's one additional. You can think of it maybe as like one additional API that just says create event bus, right? But
superset.
It's sure it's +1, right? It's
my old set had 6 things in it, and my new set has 7 things plus those same, and the 6 were the same from the old set. Yeah. I think that's how you define a superset.
Sure.
All right. So now that I'm right and I won that argument.
Well, let's do this. It's a superset as long as you use events other than AWS resource events. If you're using AWS resource events only, then they're identical. There's no difference whatsoever. Which, by the way, I think is going to be like the most common use case, right, for most folks, right? So
yeah, fair enough there. Yeah.
So there's that. So just something to keep in mind. There's these 2 things: Event Bridge, CloudWatch events. At the end of the day, under the covers, it's the exact same things, same API, same services that are driving it. It's just that going forward, Event Bridge will be the brand that it's under. And just keep in mind, you'll find both these will exist in the console in 2 different places. But when you create something in one location, it's going to be updated in the other one, and vice versa.
Cool.
And that said, you'll also run into some inconsistencies between the 2. So, and when you do, defer to Event Bridge. Event Bridge is the one that is probably going to be more actively updated. And so if you have problems with the CloudWatch Events console, you can use Event Bridge. And in particular, talking about some of the extensions to pattern to patterns and rules to have some more complicated filtering. You can't actually do that through the CloudWatch Events console, but it'll fail validation. But the exact same thing will go through on the Event Bridge console, or it will also go through on an API call to CloudWatch. It won't go through the console. So just kind of representing the fact that the CloudWatch Events console UI is behind in what's really possible there.
We cover a lot of information here on Mobycast, and if you've ever wanted to go back and remind yourself of something we talked about in a previous episode, it can be hard to search through our website and transcripts to find exactly what you're looking for. Well, now it's a lot easier. All you have to do is go to mobycast.fm/show-notes and sign up. We'll send you our weekly, super detailed outline that we use to actually record the show. A lot of times, this outline contains more information than we get to during our hour on the air. So sign up and get weekly Mobycast cheat sheets to all of our episodes delivered right to your inbox.
All right, so I think we've totally covered CloudWatch events versus Event Bridge, but maybe just moving on. We talked about, so we have these CloudWatch event structures, and that's part of what led to this digression. Is like, you need to understand, like, okay, given a particular event from an emitter, like what does this custom detail property look like? Because that's really I need to be able to extract that information to take an action against it. So how do you determine what that event structure looks like? And so we talked about, like, okay, you can go try to find examples of it in documentation or tutorials or whatnot. And this is where part of this came. So Event Bridge is trying to fix part of this with something they're calling the schema registry. And so this is where they're using the open API spec to describe the structure for events that are emitted by these services, right? And having this registry there in Event Bridge. So it does exist. If you go to the Event Bridge console, you can go into the schema registry and take a look around. There's a bunch of ones there for the AWS resources. You can create your own for events that you create for your own application. But it is open API, which means that it's all these structures are expressed. And it's pretty complicated. And really, at the end of the day, like, not too terribly easy to read. You can download language bindings for these, so you can get language bindings for like Python and JavaScript and Java. I did it for just one of the events, and it ended up being like 8 files of TypeScript code for like this one event, right? So
right, yeah. I have so many opinions about Open API that I'm just not even going to bring up on this episode.
So just know, it is out there, but like a couple things is, one, it's really heavy-handed. It's pretty complicated, and it may be just it's a lot more than probably what you need. And then the other thing is that it's not comprehensive, so there's not a schema registry entry for every event that AWS emits. So like for example, like I looked to see if they had one for the parameter store events for when a parameter store value is updated. And that is not in the schema registry under Event Bridge, right? So no luck there. So here's my recommendation for what to do is to see like what the event structure looks like. Go ahead and create a rule for the events that you want to trap, and for the target, just send them to CloudWatch logs. And so now, when you go and take an action that's going to generate one of those events, just go to the log group for that you've set up as the target, and just look at the log, and the log will dump the actual event. So you'll be able to have your own example of like what that event structure looks like. And now you'll be able to see that, save it away, and use that as your template as you go forward now and write your real target, which is probably going to be something like a Lambda function.
Yep. And so I'll just share my one opinion about all of this is that all of the schemification of XML or JSON or whatever you want in the world is never going to prevent developers from doing exactly what you just described. At the end of the day, you're going to want to look at examples and write your code around those examples. That's just what people do.
Yep. Well, and that's why, I mean, console log and printf.
Yeah.
Like, I mean, it's
that's what happens. That's what we do. We don't sit around reading schema documentation.
Yeah. So we've talked about events, the structure, kind of like how to now figure out what the structure looks like for it. So like, and again, kind of giving an example, like if I wanted to know like what a secrets manager CloudWatch event looked like when I updated a secret, I would go and create this CloudWatch rule for that. And then in the secrets manager console, I could just go in and edit my value to make it something different. And then I could go to that CloudWatch log group for that rule, and then look and see, okay, here's the structure of that. Like, what does that detail property look like? And what is secrets manager emitting? And then that gives me my roadmap now going forward. So just wanted to talk briefly. The one last piece to this we've kind of glossed over is just so the rule is important. That's that glue that connects up the input, matches against a particular event that you're looking for, and then it routes it to a target. So really, the guts of that is doing the event pattern, specifying the event pattern. And so the event pattern is another JSON object, and you're going to basically specify what fields you want to match against inside that event pattern. And so in the CloudWatch Events console, you'll get sample templates based upon what service you want to integrate with. And so if a AWS service is emitting CloudWatch Events natively, you'll see it in the dropdowns there in the CloudWatch console. So like for parameter store, it's listed underneath the EC2 SSM service. And so you can pick that, and then there's a subtype there to say, oh, I want this for parameter store, and you can pick that, and then you can further drill down and say, oh, I want to do this for updates or parameter store changes. And so when you do that, it's going to give you here's your event pattern. And really what it's going to be is, it's like we talked about that source and the detail combination, those two properties kind of uniquely identifies the emitter. And so that's what will be output for you for the event pattern. So the raw event pattern will be the source is equal to aws.ssm, and the detail type is parameter store change. And so that becomes your pattern, your event pattern, that says for this particular rule, any event that comes across where the source is that value and the detail type is that value, that's a match. And now route it to the target. So this is going to be, the crux of your rules is defining these event patterns to find it. And you can extend these, right, to drill down even further. So for this particular example, if we're looking at parameter store changes, I may just only care about the update actions, right? So that's going to be something now that's stored in the detail property, which I'd be able to see by looking at the CloudWatch logs if I just wired this up like we talked about. And then I can say, oh, I can extend my event pattern to now be where in the detail property, the operation is update. And now my event rule will only fire when there's update operations on parameter store changes in SSM.
Right. And I can imagine you can go even deeper than that, because maybe you only care about specific parameter changes.
Absolutely. So you can say I only care about this particular named parameter, right?
Yep.
So again, you just depend on your use case. What it ends up being is it's for me the realization, the aha realization was this is just field matching. And so as long as the fields exist in the event, then you can filter on those fields in your event pattern, right? So it's not you don't have to wonder well, what fields can I filter on? It's well, you can filter on any field as long as it's, and it's at the end of the day, CloudWatch event rule, it's just going to say it's whatever properties exist in the event pattern, they have to exist in the event, and they have to match in the event in order for that whole thing to match. So you can be as specific as you want, or you can be as broad or as narrow as you want on your pattern matching. But it's something just to keep in mind. The other thing to keep in mind too is that when you're doing it through the CloudWatch console, the matching is going to be exact, and it's going to be basically string matching. So you can't easily do things like wildcard matching. With parameter store, we have this concept of hierarchies, where you can refer to a hierarchy with the star wildcard. So if I have my credentials / environment, so credentials / production or credentials / development, then after that I can do /star, and that just means give me all the parameters that are in the production environment versus give me all the ones that are in the development environment. That kind of you can't do that kind of matching here in the event pattern.
Okay.
straightforward, right? You can actually do it through kind of the event bridge enhanced way, but we're not even going to go there today because that's a whole nother topic of how to do that.
In Spanish, they call it superset.
Oh dear.
Okay.
We should just rename this episode Superset. So that is the event patterns. It's a key part of the rule, and you're doing this matching. So with that, so with our particular ECS containerized application that's using secrets management, with both parameter store and secrets manager, we could have two rules set up: one for capturing the events that are emitted by parameter store, and then another one that's emitted by secrets manager. I mean, you could probably theoretically have a single rule and kind of do it but it gets a little bit messy. So you probably want to have two different rules, right? Because you're going off that source and detail type as the combination, that tuple that's going to uniquely identify what the emitter is.
Right. It's sort of like the difference between, can you do two things in one line of code, or can you just make it two lines of code? I would say make it two. Make it easier for people to track down what things are and how they work.
Yeah. Well, and I'm thinking more about it now. It's like you wouldn't be able to do anything, any kind of any matching on the detail portions, right? Because remember, if it's in the pattern, it has to exist in the event, and so you would run into
the details
problems.
are going to be way different between the two.
Yeah,
yeah,
yeah. So you'd run into problems with that. So something to keep in mind here. So with parameter store, it natively does emit CloudWatch events. So you will, when you go to create a rule, you'll find that in the drop downs and kind of build up your pattern with that for you automatically. With Secrets Manager, it doesn't natively emit CloudWatch events, which is a little bit of a surprise to me, right? Because it's newer than parameter store. It's rather new. So I was kind of surprised to see that it doesn't natively emit CloudWatch events. But what it does do is obviously CloudTrail can monitor API calls to Secrets Manager. And there is this bridge between CloudTrail and CloudWatch events. So you can get CloudWatch events generated from Secrets Manager by going by way of CloudTrail. And so this will be an option when you go create your rule. You'll see I can select Secrets Manager, but when I select Secrets Manager, it's going to say the only particular operation I have there, the only detail type I have is CloudTrail. And so you just need to have CloudTrail enabled on your account. And I think just the default level of CloudTrail is probably good enough. You don't even need to create a trail, because the trail itself is for persistence of events past X number of days. So you may not even need to do that. Not totally sure, but just realize Secrets Manager is the CloudWatch events are being captured by way of CloudTrail. And so CloudTrail is logging those API calls to Secrets Manager and then emitting the CloudWatch events. And so you're going to be looking at in your event pattern there for Secrets Manager. The source is going to be Secrets Manager, and then the detail type is going to be CloudTrail actually.
How complex that is just kind of blows my mind. And it reminds me of a thing that I'll try to link to in the show notes, which is an old spoof of the switch to Mac commercials. And it was a switch to Linux commercial from like 20 years ago. And it was like this guy saying how easy it is. It's just so easy. And he's talking about configuring his parameters and recompiling his kernel. And it's just so easy. It just works. So maybe I'll try to find that little episode and put it in the show notes. Yeah. Because that is not easy. Don't forget, you have to get your CloudWatch events through CloudTrail. Like, by the way, like there's this whole service we're not even going to talk about in this episode that you have to use to get these.
Yeah. Which, again, I mean, we talk about this all the time about just how complicated things are getting and just how much you need to know. And so, like, we're talking about something that conceptually at the end of the day is, like we said, this is a 2-step process, right? It should be really easy. Like get notified, take action. And we've now talked about CloudWatch Events. We've talked about EventBridge. We're now talking about CloudTrail. We have Secrets Manager and Parameter Store. Like, and that's just like the core stuff. We're not even talking about like the periphery of things like KMS and IAM and the roles that you need for all this stuff as well, right?
Yeah.
So it is. There's a lot there to cover, and it's it just, I think, a good takeaway there is just like make sure that you really understand some of these fundamental things. Like it's really important because it's going to pay off in spades as you go forward, right? It's kind of, you're building up that foundation that makes this stuff easier or at least reachable as you go and take on new things and try to build new things, right? If you don't understand, like, if you don't really understand like KMS and IAM and just like CloudWatch events in general, like how it works, like going forward, it's going to be really hard to do anything else other than you'll just be like looking for examples of like copy paste and not really understanding
that
how it
is
works.
like, so like, how could you trust any system that you just copy pasted and didn't understand?
Yeah.
Like you wouldn't. Like that guarantees you're going to spend a weekend up all night making your family upset with you as you try to actually learn the stuff you were supposed to learn before you put the code to production.
Yeah.
And just one other thing, like I mentioned the Slack earlier, the Slack group that I'm a part of where people don't really know about EventBridge. Somebody yesterday wrote, for nearly a complete noob, is there a good concise document describing best practices for setting up AWS accounts or AWS IAM policies for employees and contractors? ? Even better if it's accompanied by a CF or TF file. I ended up helping the guy, but my first response was, LOL, no. Of course there's not that. There's like 100 different ways to set that up. And they're all, varying degrees of best practices. So it's all hard.
Yeah, their policy, make everyone admin.
Yeah. That's what my suggestion was. I was like, oh, you're starting a startup. Like there's so much you're going to need to learn that like, don't make it harder on yourself. Like learn that stuff later, figure out the rest of AWS first, and then figure that out. Because like you've got too much to do. Like if he were to make I'm really going on a tangent here, but if he were to make a multi-account, managed with Cloud Tower setup for himself, like nobody would ever get anything done because they would be so stuck in the mud of this whole IAM setup that they don't even understand. So yeah. Anyway, so we did step 1. We got notified that something happened. Now this is fortunately the easier part is doing something about that notification.
It is, although, so take action. So now we know, hey, something changed, parameter that we care about has changed in Parameter Store, or a secret that we care about has changed in Secrets Manager. We've got this CloudWatch event. We have this rule that triggers on it, that matches on it, and then now it triggers an action. We started off with just sending this to CloudWatch log so we could see the schema of it. Now that we know the schema, we've saved it away. We can now change the target to now be a Lambda function, right? So now this gives us the ability to go and actually have some code, right? To customize like how we want to deal with this. I will point out, like, again, AWS continues to expand the types of targets, and make sure you look at the targets that are supported, because it may be you don't even need to write a Lambda code, right, to do this. So like there are actually... That
sounded so not software-y of you to call it a Lambda code, but go ahead.
Just like there are targets for things like ECS task. Like if you want to run an ECS task, that actually is just natively supported as a target. Like you don't need any code whatsoever. So you don't need to write a Lambda function that goes and makes ECS API calls to run task. You can just, it's all right there. Like it's the glue code's already been written for you, and you can just choose it from a drop down and then fill out basically a form to say like, okay, what's the task definition file you want to use for running that task, right? And some of the parameters around it. So they're going to continue to expand.
Yeah,
that
and
out.
given that this is like a probably going to start to be a well-worn path that people will fight their way through between secrets manager, key rotation, and then doing something in ECS or Fargate. Like, yeah, definitely look at that list, because I wouldn't be surprised if little pieces of this start to get pulled together tighter and tighter.
Yeah.
Less manual work.
Yeah. Yeah. So, I mean, that was one of the things I looked at. It's like, because in particular, I wanted to be able to make a update service call to through the ECS API, right? So that, because, okay, so that's the action we want to take here, right? So if a particular secret changes, basically we're just going to restart our containers. And to restart our containers, we just need to make a call to the ECS API for update service and set the parameter for force deployment to be true, right? And so what that does, it doesn't require a new task definition file or anything like that. It's going to reuse the existing task definition file, but it's just going to go through and stop containers and then restart them, right? Which is exactly kind of what we want in this case. So again, this is the no code solution to dealing with secrets changes. We could, if we weren't using the ECS integration, and specifying this as ARNs in our task definition file and having them injected as environment variables, but instead we were accessing it via the raw APIs, then we could do something a bit smarter here, where we could actually receive events inside our application when these changes happened, and then just update it inside our application. So keep track, like if we're doing a connection pooling or something like that, we could make sure that the connection string is now using the right credentials, right? And that would that wouldn't require a reboot of our service.
Right.
But that's much more complicated, right? It requires, quite a bit more code and the ability to change that code. So this is the route of, hey, we're not going to change any code. It's a little bit of a sledgehammer, but it turns out there's no downtime here. And, we're not going to change these secrets that often. So even though it feels like a hammer, it still feels like it's actually the right solution. I would recommend this, right, for folks in this situation. So the event that we want to take is we would just want to make this call to ECS to update the service. That's not one of the supported targets in CloudWatch Events or Event Bridge. So we do need to have a Lambda handler to do this. And so that's what we need to do is we'll create a Lambda function. And inside that Lambda function, it's going to be receiving the CloudWatch event as one of its parameters. And then it can inspect that event, make sure this is the event that should trigger a reboot of the containers. And then it's literally just wiring up, making the call to ECS API to say update service with my force deployment parameter set to true, and I'm done. So it's literally just a few lines of code inside of a Lambda function to now do this reboot. And that's it. Now, all that said, if you haven't written a Lambda function before, and there's a lot of steps there, with just, you need to have IAM role set up correctly for it. It needs to have permissions to be able to make calls to ECS. And
where are you going to put that function even in your repository to make sure that people know that it's there?
Yeah.
Lots of stuff to think about.
Exactly. Right. And then logging around it and everything else. So, but we're not going to go into that in details now, because that would be another episode or two.
Yes.
For sure. But, at the end of the day, that's what it ends up being is it's just pretty simple. It's a few lines of code inside your Lambda function to go invoke this API call, and your containers are rebooted. And so it's easy as step 1 and 2, right, John?
As easy as step 1 and 2. I mean, I guess we were going to talk through, and we should hopefully get through this in a few minutes, but basically I kind of get that, but I just have questions. Okay, I can go restart the ECS service, but I mean, while that's restarting, you said there's no downtime, but my database credential changed. Didn't I just lose my whole database pool? What if, the moment the secret gets rotated, there's still requests coming in and they're trying to get to the database, but the key changed. So what happens?
Yeah, so I mean, it just depends on. So I mean, maybe we just like put it all together now. Like, so I kind of went through this process for my own personal blog site, and so it is it's running the Ghost application for blogging, which is a Node.js application that's containerized, running on ECS. It uses MySQL, a MySQL database as an RDS instance for persistence, right? And so it's using Secrets Manager for the database, basically the database connection string, right? And so that gets injected as an environment variable upon container startup for the Ghost application. There's a little bit of Bootstrap code there that from that environment variable, it configures Ghost the way that it wants to be configured for a database connection string, and then away it goes. And so now, and then I've set up automatic credential rotation in Secrets Manager for those RDS credentials. And so, what happens there is whenever it's time for the credentials to be rotated, Secrets Manager goes and updates the secret, generates a new secret, right? The CloudWatch event is now emitted onto the system of bus. I have my CloudWatch event rule that's pattern matched on these particular events. So that fires and invokes a Lambda. The Lambda function then makes that ECS API call to force the new deployment. And then I've set up my service properties on the ECS service such that the minimum number of tasks is set to 100%, and the max is set to 200% of the desired, right? So like, I think I only need one task running. So I have the desired set to one task. I set the minimum to 100%, the max to 200%. And so when I do that force update, what's going to happen is ECS is going to create a new task running the container, right? That's going to get the new credentials from Secrets Manager and make this connection. And then once that's up and running and reports healthy, it then kills the old one.
Sure.
And so you probably do have this small window where if you're still running the old one and requests come in and a new connection to the database has to be made, then that's going to fail.
The key right there.
Right?
That last little thing you said. So if there's existing connections to the database, when the secret changes, they still work. They don't get
They're
killed?
still going to work, right? Because they already connected, right? They don't need to re-authenticate. They authenticate when they're connecting to the database. Once the connection's open, right? It's not continually re-authenticating. So it'll be fine as long as the connection's open. It's only if you have to establish a new connection. So, chances are your application is doing things like connection pooling, and it's got a pool of these connections. And so even if you do have a request coming in to say, oh, I need to go, make this connection to the database, it may be reusing something that's already in the pool. How long, again, this window is it doesn't have to be long at all. Again, depending on how you've set up your service. Like mine, I have it set up so it's within about 60 seconds. That old container is going to be expired. So it's a very, very small window here for that. And so, which is, it's pretty good, right? It's pretty good bang for the buck considering that we didn't have to write any code.
Right. Yeah. Except for that. Yeah. That Lambda code.
Except for the Lambda code. Yes. Yes. The Lambda function.
Yeah. Cool. Well, yeah, that's pretty cool. We definitely left that as an exercise for the user at the end of the secrets management thing. And, I kind of had this like weight on my shoulders that was not, that's like a classic exercise for the user. Like in the math book, it's like, hey, when you're at home, you should try proving that 1 + 2 = 3. Yeah. I don't know how to do that. So yeah, a big one, and it's good to finally talk it through and to see that it is big. It is hard. And, AWS has a lot of pieces in place to help you do it without much code. But, just understanding how those pieces all fit together is not something that you just happen upon by accident.
Yeah. Yeah. And, at the end of the day, I mean, the end result it's pretty cool. I kind of decided, I want to know when some of these things are happening. So I updated the Lambda function to emit an SNS message to a topic when it does the force deploy, right? Because I want to know like when that happened, and then also I want to know once my ECS system reaches steady state. Because this, I've set up now automatic credential rotation with Secrets Manager for these RDS credentials, right? So something just to know, like, hey, when does that happen? And make sure that when it does happen, that everything is successful. So it's kind of cool to see all this stuff working end to end. So now if I go into Secrets Manager and I force a rotation, it's literally within a few seconds, I get an email saying, hey, your service is now rebooting. And, 60 seconds later, I'll get another email saying steady state.
Nice. That's so fun.
Right. So, and that would be kind of interesting. Like, I think I've set it up for a 30-day cycle. So the next time when it happens automatically, like, I'll know because I should see these 2 email messages letting me know that, hey, doing the force reboot, and now we're back to steady state.
Right. And then there's my other cynical side that said the fact that this is so complicated is the catnip that makes AWS so successful. Because, right, like, how fun is it? You just built a Lego, Starship Enterprise, right? And when you push the little button, like, it shoots laser beams. And, like, that's so fun. So fun.
Yeah.
Cool.
Yeah,
all right.
indeed.
Well, thanks so much, Chris, for talking us through that Lego Starship Enterprise.
It's my pleasure, John.
All right. Talk to you again next week.
All right. Thank you. See ya.
Bye.
Bye.
Thanks for being aboard with us on this week's episode of Mobycast. Also, thanks to our producer, Roy England, and I'm our announcer, Stevie Rose. Come talk to us on Mobycast.fm or on Reddit at r/Mobycast.